Hi friends, myself B. Himan. Today my topic is about assessing physico-chemical parameters of drinking water quality. Introduction. Nepal is a small landlocked country located in between China and India. Ice capped Himalayas, glaciers and more than the 100 small and big lakes make Nepal a richest source of water. Water is the most common, widely distributed and useful liquid on Earth. Almost 2 by 3 of the Earth's surface is covered by water, existing in all the three major states. The human brain is 85% water. Muscles and bones contain 77 and 33% water respectively. Good water, drinking water is of the fundamental importance to the human physiology and has direct impact on health. Total population has access for proper water supply schemes. Natural water is generally used for drinking and other domestic purposes in the area. In the absence of fresh water supply, people residing in the area use borewells for water domestic and drinking purposes. However, an extensive analysis has not been conducted to determine the quality of drinking water. So the investigation aimed to evaluate its physico-chemical parameters like pH, alkalinity, TBS, BOD, turbidity, salinity, inorganic major anions and trace heavy metals were analyzed to assess the quality of drinking water collected from the different sample stations in Dankuta municipality. Correlations between the metal concentrations were also investigated. Materials and methods. All the chemicals and standards used for the preparation of reagents and solutions are of the highest purity. Analytical reagent grade available. Triple distilled water was used throughout the analysis. Alkalinity of water samples were determined volumetrically by strong acid titration method. Total hardness was determined by complexometric titration method using standard EDTA with ammonia buffer and ureachrome lactate. Trace heavy metals like lead and arsenic contents were determined by standards prescribed by alpha using variant fast subsequent atomic absorption spectrometer. The water samples of anion analysis was filtered using an operated vacuum pump equipped with a 0.45 μm cellulose. Results and discussion. Dissolved oxygen. In the present study, DO in September 2014 ranges from 3.4 to 7.8 ppm. The minimum tolerance range is 0.4 ppm for drinking water. Biological oxygen demand. Biological oxygen demand is a measure of the amount of oxygen consumed by microorganisms in the oxidation of organic matters in 1 liter water sample. When organic matter such as dead plants, leaves, grass clippings, manure, sewage or even food waste is present in your water supply, the bacteria will begin the process of breaking down this waste. When this happens, much of the available dissolved oxygen is consumed by aerobic bacteria, robbing other aquatic organisms of the oxygen they need to live. pH. Dissolved gases and industrial waste affect the pH value of water, and this finally changes from the test of drinking water. In the present study, pH in September 2014 ranges from 6.7 to 8.90. The tolerance pH limit is 6.5 to 8.5. Some sample stations had higher pH than prescribed range. In October 2014, pH ranged from 7.67 to 9.602. Turbidity. The turbidity in water refers to the loss of transparency caused by the presence of clay, organic matters, microscopic organisms and other particulate matters. In the present study, turbidity in September 2014 ranges from 0.04 to 2.35 NTU, and in October 2014 turbidity ranges from 0.16 to 2.60. The tolerance range from turbidity is 5 NTU according to WHO guidelines. So the sample station has shown on lower NTU values than the prescribed range. Electrical conductance. The electrical conductance of water is due to the dissolved mineral ions. All the water sample taken under investigation have measured electrical conductivity below Hu limit, which is 1500 US per centimeter. In the present investigation, electrical conductivity of water sample was observed to be in range of 234.7 to 235 μs per cm. Total dissolved solid. Various types of water soluble minerals and organic matters donate total dissolved solid. Concentration of dissolved solids in water is an important parameter and that determines the quality of drinking water. The analytical data for all the water samples in our investigation ranges from 9.2 mg per liter to 118 mg per liter, which is lower than WHO and National Drinking Water Quality Standards value. Salinity. In the present study, salinity in September 2014 ranges from 280 to 3160 ppm, and in September 2014 salinity ranges from 230 to 2350 ppm. Alkalinity is the measure of acid buffering capacity of water. The alkalinity of water is due to the presence of hydroxide, bicarbonate and carbonate ions. The WHO limit for alkalinity of water is 200 mg per liter and the permissible limit of 600 mg per liter. Beyond this limit, the taste of water becomes unpleasant. In the present investigation, the alkalinity of water sample ranges from 100 to 650 mg per liter. Phosphate. In the present analysis, phosphate in September 2014 ranges from 13 to 41 mg per liter, and in October 2014 phosphate ranges from 10 to 39 mg per liter. The evaluated value of phosphate in the present study is higher than the prescribed value. The higher value of phosphate is mainly due to the use of fertilizers and pesticides by the people residing in this area. Nitrate. In the present analysis, nitrate in sample water was ranged 56 to 420 mg per liter for the surface water, which is due to excessive use of fertilizers in agriculture to sweep the reserved water used for drinking and domestic purposes. However, the well water samples have very low nitrate content, therefore 0.84 mg per liter, which is far below the tolerance range 20 to 45 mg per liter suggested by WHO. Sulfate. In the present investigation, sulfate concentration of water sample ranges from 30.28 to 62.07 mg per liter in September 2014, 19.25 to 59.55 mg per liter in October 2014. The tolerance limit range of sulfate is 200 to 400 mg per liter. Total hardness. The presence of divalent metal cations, especially calcium and magnesium in the form of bicarbonates and sulfates, represent total hardness. It determines the quality of water for drinking and domestic purposes. In the present study, the total hardness in September 2014 ranges from 115 to 960 ppm, and October 2014 total hardness ranges from 85 to 820 ppm. The tolerant range of total hardness is 300 to 600 ppm. Chloride. Chloride is one of the major inorganic ions in water in potable water. The salty taste is produced by the chloride intended for public use as prescribed by WHO. In the present study, chloride in September 20 ranges from 112.2 to 1465.7 mg per liter, and in October 2014 it ranges from 68.9 to 1257.5 mg per liter. The tolerance range for chloride is 200 to 1000 mg per liter. Fluoride. In the present investigation, fluoride is different in different water samples ranges from 0.8 to 1.2 mg per liter, while the tolerance range for fluoride is 1 to 1.5 mg per liter. Low fluoride concentration prevents dental caries. However, it has been observed when fluoride intake through water, food and air increases to the specific level, the beneficial effect is lost, and in fact harmful effect begin to show with increasing concentration. Ammonia. In the present study, ammonia was found 1.04 mg per liter, which is under tolerance limit and was accepted to come from organic matters in the water stream. Lead highlight content in drinking water causes skin damage, circulatory system problems, and increased risk of cancer. In the present investigation, the concentration of lead was below 0.005 mg per liter, which is under the tolerance limit. Arsenic. In the present investigation, arsenic was analyzed to be lesser than 0.005 mg per liter, which is below the tolerance limit suggested by WHO. Bacteriological analysis. The bacteria pathogens isolated from water samples in the water included Escherichia coli, Enterobacter aerogenes, Pseudomonas, Staphylococcus aureus, Salmonella, Typhosa, Shigella, Vibrio chlorata, Proteus, Klebsiella. The present investigation, the total coliform was found 8 counts per 100 ml and fecal coliform was 6 counts per 100 ml. According the total coliform count for all the samples were exceeding high. Conclusion and recommendation. The different samples of potable water used for drinking and domestic purposes in Dankuta municipality collected from the various places were found have bacteria and mineral contaminants, although some of the metals and ionic concentrations were under the tolerance limit, but they may cause great human health problems. Hardness of water was beyond the tolerance limit. High ionic concentrations level in drinking water samples also suggest that treatment is required for drinking. However, the pH level is variable at different sample sites. In conclusion, proper well location and construction of human activity to prevent sewage from entering water body are the keys for the bacterial contamination in drinking water. It is evident that the waterborne diseases are due to improper disposal of refuse, contamination of water by sewage and surface runoff. Therefore, programs must be organized to educate the general populace on proper disposal of refuse, treatment of sewage, and need to purify water to make it fit for drinking. Because the associated organisms are of public health significance, being implicated in form of infection or the other in areas lacking in tap water, as in rural dwelling. Educative programs must be organized by researchers and government agencies to enlighten the villagers on proper use of surface water. Thank you.